Hello there, welcome. We have a question here. It is a trigonometry question, elementary trigonometry. We have a triangle ABC with angles capital A, capital B, and capital C, and the opposite sides to the angles are small a, small b, and small c. What we have to find, the question is, if a squared, the side a squared, is equal to b times b plus c, we have to prove that angle A is double of angle B. We are going to use the law of cosines, Al-Kashi, in this one, and we are going to use it to solve this problem. It is the best one actually to use when you want to find angles. And we just said that a squared is equal to b times b plus c. If we distribute, we get b squared plus bc. And the law of cosine, if you go for angle A, and we have to use the small side, the opposite side A. So we say a squared is equal to b squared plus c squared minus 2 times bc times cosine of angle A. This is the Al-Kashi or law of cosines. So we are going to use that one, and we are going to replace, to substitute a squared by its value, and we can pull out that is negative minus 2bc cosine A is equal to a squared minus b squared minus c squared, and multiply by negative 1, we get 2bc cosine A is equal to b squared plus c squared minus a squared, and definitely we get cosine A, the angle, is equal to b squared plus c squared minus a squared, all over quantity 2 times bc. Now we have to substitute a squared by its value here, which is b squared plus bc. So that will yield the following. You will get cosine A is equal to b squared plus c squared minus b squared minus bc, all over the quantity 2 times bc. And we see b squared minus b squared, we just simplify that, and we get c squared minus bc over 2bc. We can factor the c in the numerator here. We can say it's equal to c factor in c minus b over the quantity 2bc, and then we simplify by c, and we get, of course, the value of cosine A is equal to c minus b over 2b. So this is cosine angle A. We have to make sure that we find cosine angle double B. So if A is equal to B, so cosine 2B should be equal to the same value. So we have to prove that cosine 2B is equal to c minus b over 2b. And we go to get that, we go to our formula saying cosine 2b is equal to cosine squared b minus sine squared b, and we can also say it is cosine squared b minus the value of 1 minus cosine squared b, right? And that gives us cosine 2b is equal to 2 times cosine squared b minus 1. Alright, so we have that. We are going to use the next screen. So we found that cosine A is equal to C minus B over 2B, and we also found that cosine 2B is equal to cosine squared B minus 1, and we want to prove that cosine A is equal to cosine 2B. So we have to calculate 2 cosine squared B minus 1. But we know that from Al-Kashi that B squared is equal to A squared plus C squared minus 2AC cosine angle B. So we can pull out cosine angle B the same way we did for cosine angle A. Say cosine angle B is equal to A squared plus C squared minus B squared all over the quantity 2AC. Now we have to substitute, to make a substitution, right? Replace A squared by its value. Remember we found in the prompt that A squared had to be B times B plus C, or B squared plus BC. So we are going to use that, and we say then that A is equal to square root of B squared plus BC in that situation. So we have A squared and A, so we plug them in. So cosine B is equal to A squared, so B squared plus A plus BC. Now plus C squared minus B squared all over quantity 2 times A times C, so 2 times C times square root of B squared plus BC. Correct? And we see B squared minus B squared here, and we can put C in factor if we want, yeah? So you can see factored B plus C over quantity 2C times square root of B squared plus BC. So you can simplify by C. So we found cosine B. So we found cosine B is equal to B plus C over 2 times square root of B squared plus BC. Now we have to plug in cosine B into the value of cosine 2B. So cosine 2B is 2 cosine squared B minus 1. We have to plug in there, and that will show that cosine 2B is equal to 2 times B plus C over all this 2 times square root of B squared plus BC all squared. All squared minus 1. So we are going to calculate this, and we can say that cosine 2B is equal to 2 times cosine squared B. That means 2 times B plus C squared over 4 times B squared plus BC minus 1. So we can develop the numerator. We can say that, simplify here first, and then on the numerator we get B squared plus 2BC plus C squared and over 2 times B squared plus BC. Excellent. So we have that, and then minus 1 here, and we are going to the next screen, and we are going to get this one here. We remind ourselves that cosine A was found to be C minus B over 2B, A squared was this, and then A is equal to B. So we continue our operation. We say cosine 2 cosine squared B minus 1, which is equal to cosine 2B. We continue the calculation here. We can say it is B squared plus 2BC plus C squared over the quantity 2 times B squared plus BC. 2 times B, actually you can put B in factor. 2 times B, factor in B plus C. Okay? And then say minus 1. Minus 1 here we can put the same denominator now. That becomes minus 2B, factor in B plus C over 2B, factor in B plus C. So we have the common denominator now, so we can say that we get B squared plus 2BC plus C squared minus 2B squared minus 2BC all over the quantity 2B, factor in B plus C. That yields, we can do some simplifications here. 2BC minus 2BC, and B squared minus 2B squared, but we remain with 1B squared here. And we get finally C squared minus B squared over 2B times B plus C, which is C plus B, factor in C minus B over 2B times B plus C, or C plus B. We can simplify here, and we got that cosine 2B or 2 cosine square B minus 1 is equal to C minus B over 2B, which is the same value as cosine A. Therefore, A is equal to 2B. Thank you. See you next time.